In this video, I'll be explaining the Scanline algorithm. So here is the question. We'll be given an array of, I've taken the size 6. So we've given an array of size 6 and every element of it is initialized to 0. And we'll be given q queries. I've taken q is equals to 3 and value, I've taken it 2. So for each query, we'll be given two integers L and R. So let's take 1 and 4, 3 and 5, 2 and 3. These are our three queries. So what we need to do is we need to increase the value from index 1 till index 4, that is from index R till index L, from index L till index R, and increase their value by 2. So from 1 to 4 we need to increase their value by 2. So the array will become 0, 2, 2, 2, 2 and 0. And to the second query, if we come to the second query, we need to increase the value from 3 to 5. So that is from here to here. We will add the value 2, so 2 plus 2 is equals to 4, 2 plus 2 4, and 0 plus 2 2. And these three will remain the same. So these are the modification after the second query. For the third query, we will add the value from index 2 to 3. So it will be 0, 2, 2 plus 2 4, 4 plus 2 6, and these two will remain same, that is 4 and 2. So this should be our output of the given question. So if we see the time complexity, if the L is 0 and the R is n minus 1, we can see that we need to traverse the whole array to make the modification, right, from here to here. So we need to traverse the whole array for each query. So the time complexity clearly would be n into q, as we need to traverse the whole array for each query. So coming to the Scanline algorithm, we can solve this by lesser time complexity. So what we do here is, let me make an array of 6 initialized to 0. So what we do is we take L and increase the array at the L position by the value. So it's a 0-bit indexing, so 0, 1, 2, 3, 4 and 5. So at 1 I'll increase the value by 2. At R plus 1, that is 4 plus 1 5, will decrease the value by value, and others will remain same. So this is the modification after our first query. For second query, we'll do the same thing, increase the value at index, that is 3 will 0 plus 2 will be 2, and decrease the value at 5 plus 1 6 doesn't exist, so we don't need to do that. So and the other elements will remain same. For the third query, we'll increase the value at index 2 and decrement the value at 3 plus 1 fourth position minus 2. So this is the modification after the third query, and what we do now is we take the pre-sum of this array. So after taking the pre-sum, it will be 0, 2, 2 plus 2 4, 4 plus 5 added 3 here, it will be 2, just a second, yes, so 4 plus 2 6, 6 minus 2 4, 4 minus 2 2. So we can see that the output here is the same as this. So this is how the Scanline algorithm work, and the time complexity, as we can see, is we are just updating the value of the a of L and a of R plus 1. So this both operation are big O of 1. Alright, so for each query it will take big O of 1 operation to do the modification. So the time complexity would be big O of q. So as we can see that we have made the time complexity from nq to q, And for each query, if we do the prefixSum after the second query, so this will be equal to 0, 2, 2, 4, 4, 4 minus 2, 2. So we can see even after the second query, if we take the prefixSum, the query will be equal to this. So that's how the Scanline algorithm works. It's based on the concept of the prefixSum. So it can be used in many questions to decrease the time complexity. So now I'll be implementing this algorithm. So I'll be doing it in C++. So here we make integer n and q. We take input of n and q. N is the size of the array and q is the number of queries. And we make an array ARR of size n and initialize every value of it by 0 as in the question. So we'll run a loop of in q times q minus minus is greater than 0, and we'll take two integers int l and r, take the input of it. Now what we'll do is we'll update the value of ARRL and increase it by value. We need to make the integer value equals to 2, and we'll decrement the value at r plus 1. Yeah, so after q queries we have to take the prefixSum of the array. So I is equals to 0, 2 and minus 1. And we also print the array. So I have taken the input 6, that n is 6, query is 3, and these are the 3 queries as discussed before. Yeah, so as you can see, it's giving the output 024642. In the next video, I'll try to solve more complex problem on this algorithm, Scanline algorithm. Thank you very much.